Something really interesting is happening this year, despite the majority of pundits proclaiming that DevOps was going to eat IT, with containers and microservices leading the way. Instead, IT departments, just like yours, from small teams to the largest organizations, are taking on production container management just like any other technology. And that's really encouraging because it means that IT really can do just about anything. The trick, of course, is how to monitor both containers, which are for the most part based on standards, but also the services that run inside them. And that's often microservices. So today, we're going to show you how to use the new features of SolarWinds to monitor both, along with just about everything else in your environment. Welcome to today's THWACKcamp session, Monitoring Microservices, IT's newest hot mess. I'm Head Geek Patrick Hubbard.
I'm Lee Calcote, Head of Technology Strategy.
And I'm Carlo Zatilny, Principal Architect. But most of you on THWACK know me as Carlo.Zatilny.
Carlo gets to build all the new coolness. But we're really happy to be doing this session in 2018. We thought that it was going to be a little while longer before we could do a session on untangling microservices. You know, what are they? How do they work? How do they change your approach to monitoring? Basically, does IT have to adapt to get them into our dashboards alongside everything else that we're managing?
All right. And you've probably heard us talking about the SolarWinds IT Trends Report. It's a survey we've been running for a few years. It lets us track what's really happening in IT. Not just customers, but a broad set of technology professionals, from admins to execs to frontline management. And we've seen a heavy uptick in the importance of containers to our respondents, essentially half of which in the 2018 report ranking containers as really important technology critical to their success.
True. Also, containers are dragging a host of new changes, like distributing application components away from traditional monolithic architecture and adding a lot of open source, Linux, and other tech, which might be new to you. And one of the biggest drivers of containers is microservices, or at least one of the byproducts of containers is facilitating microservices.
Right. And you might think that you need something radically new to manage this, but that's not really true. Now, if you're cloud, if you're DevOps, heavy microservices, and otherwise kind of fall into that bucket of cloud native, then you might want to take a look at SolarWinds cloud tools. That's AppOptics, Papertrail, Pingdom, and Loggly. They're SaaS-based, and they're designed for developers. But if you're using the Orion platform, either on premises or maybe even installed in Amazon, Azure, or GCP, you might be surprised to know that you already have what you need to monitor microservices and containers.
Assuming you've upgraded to the latest version.
You know, and actually this year at Cisco Live, more of you told us that you're up to date on the latest bits than ever.
Mm-hmm. The new installer.
The new installer.
Yes, magic. But even if you've upgraded, you might not know a lot about microservices or how to use the new features of Server and Application Monitor and Virtualization Manager that let you monitor containers pretty much out of the box. So in this session, we're going to walk through 4 areas of how-to. First is container infrastructure monitoring in SAM.
Yeah, basic container infrastructure information. So container metrics, image details, environment variables, and more.
Yeah, absolutely. And then the second one is going to be AppStack. And many of you already are familiar with AppStack. That's the technology in the Orion platform that automatically connects elements like applications to infrastructure to virtual machines. But did you know that it also does that for containers as well? We're going to show you how.
Well, and third, we'll show you how to include microservices and how to bring performance signals across your containers under a single view within PerfStack. So think of PerfStack as a microservice composite visualization and root cause troubleshooting tool. The goal here is to stop boomerang tickets.
Yeah, right. And the last thing we'll talk about is AppOptics for SolarWinds Orion.
Distributed tracing.
Yeah. Microservices make it easy to embed rich metrics and logging regardless of the language, but also maybe you want to use the platform to inject tracing data for existing apps.
Well, distributed tracing is a missing link here. And we've been helping standardize instrumentation formats through our efforts with open tracing and open metrics. AppOptics for Orion is the missing piece that brings traceability across your distributed applications, across your microservices.
That's awesome. And it sounds like it's going to be a pretty jam-packed session. So let's go ahead and do this. Let's start with just a brief definition of what microservices are and a little bit about how they're kind of packaged in containers, because that's something that maybe not everyone is familiar with. And then let's just start by showing how to configure the built-in container monitoring in Server and Application Monitor. So let's start by just taking a minute and talk about microservices and a little bit about containers. Or maybe it's a lot about containers and a little bit about microservices, because it really comes down to sort of how you break out an application, right? Like once upon a time, you had this sort of single monolithic process, or once upon a time, I think still an awful lot of the time, right? So you have everything. You have presentation, logic, all of it combined in one black box, and then it's got some sort of stateful backend that probably runs as its own process or set of processes. And we tried to get a little bit better, right, with IT, where we went to sort of an in-tier approach, right? We broke out components into different services a little bit, but they were still really tightly coupled. So how are microservices different?
Yeah, well, first of all, they're a bit more complicated. The world was a much more simpler place back then, and is still now for many. Microservices bring the promise of speed. They're often found in environments where you're continuously delivering. I think this kind of started back about 5 years ago when Docker had popularized the use of containers and made them a very portable format. And what's been happening since then, particularly as engineers create new software projects, that they find themselves leveraging containers and taking more of the microservices approach. And pretty soon they find themselves with probably back into the land of VM sprawl, but now it's container sprawl.
Well, the thing that always powers sprawl is sort of decreased barrier to creation. So it's almost another layer of ease of creation and deployment, right? So first it was VM, but you were still carrying the OS, and then an application inside of that, plus all of its configuration artifacts. And now you have something that's so lightweight that literally they're just ephemeral. You don't really care, and as long as I have enough of them horizontally distributed and they're working okay, even if the dashboard's got a bunch of red on it every now and then because, hey, this thing popped up, but it seems to be okay and the service is operating okay, that's really different as opposed to just having this nice stack of monitored tech.
Yeah, it shifts some of how we do monitoring around. The paradigm begins to shift. It's not necessarily about high CPU utilization being bad. It's, in fact, maybe that's what is desired, to get a lot of efficiency out of your resources.
Right. Well, and then the other thing that's kind of interesting about it is that you sort of start breaking things down sort of by how those services work, right? Are they stateful? Are they stateless? Like you might have a microservice that's just about compute or business logic, and then other ones that are tied or maybe bolted a little tighter to a back-end store. And then the other thing that's kind of interesting is, before with a monolithic app, you have a user interface and all of the other components, sort of the presentation layers are all running in one monitorable thing, right? So if I have SLAs for how fast my pages should load and what my IOPS look like and a couple of other things, I don't know for sure what that user experience is like, but we can kind of infer what they are, and everybody seems to have agreed that that's a reasonable agreement. But when you get into microservices, what you're really starting to do now is make it about that user interface, or at least the consuming process, right? So that you have a set of services and they each may have backends, but each one of those has to be monitored separately because they're no longer all kind of wrangled up and placed into one group. And especially when they're sort of popping in and out of existence, that makes that really challenging.
It does. And while developers may have benefited from the speed by which they can deliver and do that somewhat independently in their own different service teams, things haven't necessarily gotten easier for the operator. It turns out there's just a proliferation of any number of things to monitor now. Turns out that there isn't necessarily a single entry point into that application, but from the looks of it, many different entry points.
Right, especially when they sort of pop, you might say, oh, how many containers did I create this week? 100. Well, that would already be typically more than a lot of people do in terms of virtual machines. But if it's 1,000, if it's 10,000 container instances per week, and that's just normal, and everything's running great, that's a lot to try to figure out. There's just no way to kind of manually create all of that monitoring. And then the other thing that gets more interesting is the way that this is supposed to work. Ideally, the whole point of doing microservices in the first place is to loosely couple those services, right? Make them small, targeted at doing one specific thing, and then it makes them interchangeable. But then you start thinking of kind of services of services, and the whole idea of what is the back end, or what are the dependent data stores for that, almost disappears because you were literally just consuming a set of services, sometimes without a lot of knowledge about where that data is coming from.
And you've got to have the right tools in place when you get to services of services. It's about their APIs. It's about the way in which those services are interacting. If you don't have the right tools in place, you're going to be running blind.
So what else do we need then? We just all we have to do is just upgrade server and application monitor and virtualization manager. We're just good to go, right?
Sure, yeah. Look, I think we start there.
Right.
And then we acknowledge that what we've accomplished is a much better insight into container infrastructure itself. Mm-hmm. And as we go to consider the needs of the application, how they're performing, and really what business level metrics they are tracking and that we should be monitoring. We start to get into the digital experience monitoring. We start to really track those things that are important to the business.
Right, and especially because you start thinking about things like, not only is root cause analysis something that's, I don't know about wildly different, but certainly extended in potential complexity when you start talking about ephemeral containers and logging and events. But the other one is like, to your point about metrics, new metrics. Like there's one like error rate. And I don't know how many of you have like error budgets, if that's something that you've talked about in your teams before, sort of like you would with any other budget for cost or an SLA, which is, hey boss, as long as we don't go over this many errors in a time period, don't bug me about performance for this application, because it lets you then budget, just like you would with dollars as a part of actual hardware, lets you budget your own changes, your own risk, your own potential upsides as a part of that deployment process, right?
Yeah. And error budgets aren't the only thing that you need to start tracking with microservices, but also retry budgets. What happens when one service tries to call the next dependent service and it can't reach it?
And we're about to look at that in just a second. You're going to actually show us some reports that can actually give us things like restart metrics and other things, even in extremely high volume applications like that. Right. And then the last one is, and it's really interesting, you think about an application, about turning, where you have that sort of end consumer from a data perspective as the endpoint, turning that into the ultimate monitoring node. Right, where if I look at human behavior that's attached to that service or business value, and let's say you have a booking service and I'm watching upsell, right? More elements added into a catalog or into the cart, or maybe I'm going to upgrade to a more expensive room for a hotel. That's telling me whether or not the application is doing what it's supposed to. And if that rate starts to come down, that tells me there's something probably not right. Page abandons or something else like that.
This is probably a tired sentiment, but the applications and their business value are really why we're here, why we monitor that infrastructure to make sure it's working. And so really, we're just kind of getting started here. So Carlo, I think what everyone would love to see here are screens. Let's start with adding a container monitor.
Sure, all right, let's go to our classic Orion settings page.
And so this is SAM 6.7.
This is SAM 6.7. You'll also see this in VMan 8.3, where we've added this new Managed Container Services piece to your settings page.
Okay.
Clicking on this takes me right to our container services, and here you see I've already added a couple of apps for us to look at, including one Docker app and another Kubernetes cluster.
Is it Kates or K8?
Oh boy.
I say Kates, but feel free to disagree with me.
Once we all get it, then it changes.
Yeah. So if I wanted to add container monitoring to my Orion platform, what I need to do is come in here and click this How to Add button. And what this is bringing up is it's giving me the opportunity to identify what type of environment that I'm going to be monitoring. So here at THWACKcamp, I get to choose if I'm going to be running a Docker environment, Kubernetes, if I've got Docker Swarm running, or Apache Mesos as well.
So did this appear, I guess in this first edition, this appeared with all 4 out of the box? So
that's
both
correct.
Flavors of Docker, Kubernetes, and Mesos.
That's right.
And whether you're using an orchestrator or not.
Exactly. That first option that I showed is really about just I'm running Docker without an orchestrator, but I'm running it as a container platform, and I just want to be able to monitor my containers, whether those are the microservice-oriented containers or if they are containers that I'm treating like a VM. So they're long-lived containers that I've just been able to build, and I'm going to run them and treat like a node.
And it's so interesting because one of the reasons that we did that was a lot of conversations with you is that some of you, you can see wherever possible, we like to use an API to get at data, right? And with orchestrators, with those sort of large container managers for, I guess, Mesos and Kubernetes by default, both are based on orchestrators. And then you kind of have that option of using Docker Swarm or Docker, sort of almost like vCenter versus ESX. right? So, but one of the reasons we added that was a lot of you were sort of in between. Some of you were all in on orchestrators, and then some of you have just sort of standalone instances, and this lets you easily get started with just that one instance, or even just experiment in your lab.
That's right. So we have adopted the common methodology for monitoring containers with containers. So what this get script actually does, and I can copy this to my clipboard now, is this generates a URL for a curl command and then ultimately a sudo command that I'm able to run from my individual host. And this will grab containers down from Docker Hub and be able to deploy containers into your environment that will actually end up doing the monitoring and sending the data back up to Orion.
Yeah, I think, Patrick, you missed maybe the real question. It's not K8s versus Kubernetes. It's probably kubectl versus kubectl.
Oh, Lord. Yeah, well, okay, but the other thing here too, and I was going to make a joke about, no, wouldn't you rather just do all of this YAML, by yourself manually? And the answer is no, you really would prefer not to do that. This makes that really easy because you're not worried about, in this case, I guess this technically is a sidecar, right? Sidecar monitoring. So it's going to take care of building that for you and then pull that Docker image down, and then in this case, Kubernetes is going to go ahead and create an actual container based on that image.
Right, exactly. It's going to look at your environment setup, so whether you're running Kubernetes in a cluster or if you're running just one individual Docker host, it's looking at that and it's able to distribute the necessary containers that we need to monitor your entire environment, and we do that just with these 2 lines of scripting, and it brings all of the necessary components and gets us ready to go so that we're able to show you full on what's going on within your environment. So I will X out of that, but we can just dive into what this actually does. So once I've added my container monitoring, what it does is it then lists the services that I already have. So we can simply click on one of these and go look at everybody's favorite node details page. Everybody's, of course, familiar with node details and the amount of information that it gives you. And what we've added is some new screens or some new widgets to the node details page. Notably, you'll know at the top, our classic app stack environment widget has containers added to it. Containers are now first-class citizens within Orion, so everything that you think that you can do with applications, nodes, interfaces, all of the different things that you love in Orion, we also have containers as those citizens, so alerting, reporting, everything is available for containers. We also added this new containers widget, which is now listing all of the different containers that are running within my environment. And in this case, this is my Docker host. So it's got just a bunch of different Docker containers that are running on the host itself. And so everybody's now anxious for me to click on a container details page.
Pick one that somebody put SSH in. Don't put SSH in your containers.
Yeah, don't put SSH in your containers. So now
SNMP, that's what we really ought to put in
containers.
Yes,
I will bring up an SNMP container.
I think I need to put something in Docker Hub that's actually a little Go app that's got an SNMP hook, just so we can say that we did it, but anyway.
For all the rest of us who write containers, please don't. So here is our brand new container details page, and this is where we really think that you'll land when you need to look at a specific container and find out what's going on within that container and its history. So of course we have all of the information about the container itself, what type of container it is. Here you see I'm running a Kafka container, and it's been up for 17 days, and that's good for me. It's got some different image details about how much memory it's using, and then all of the different environment variables that are associated with this different image. So here you get a lot of information about your specific container, about your environment, that helps you understand what's going on in the container and helps developers, if they're looking at the screen, be able to know if there's something missing or misconfigured.
And in this case, it's also telling us that we're using which of the Zookeeper connections is the registry for this one.
That's right. For this specific container, it's talking to a Zookeeper instance, and so of course that's one of the environment variables for it to be able to find its specific Zookeeper instance.
It looks like it's also telling us about our dependencies, about where our containers are actually running and what infrastructure is actually hosting those.
Yeah, so this is again another app stack environment piece. So I have my server, so I'm able to access my server from this page, and this is the instance of the container that is the specific instance of the container that we're looking at on this details page, but it also associates any applications that I might have created, and we'll get to that here in a little bit. I'll actually show you how I'm monitoring this infrastructure with an application, because ultimately when it comes down to it, we've been discussing application is king, and containers and microservices are really just a methodology for me to deploy an application, and I really care about the application and how it's running.
The other thing here too that I really like is the environment variables breakout here, because in this case, a lot of times you would think you would have a specific set of properties that are always the same. We look at nodes, for example, or you looked at maybe a VM, you would see kind of the same variables, but in this case, it's specific to the startup variables that are a part of that container. So for example, in this case, if this one is actually using Alpine, I guess, as its base image, but if I was starting from scratch, I wouldn't have these. I might have something else. So then these are dynamic, and they're going to be based on the nuances of that specific image.
Right. And of course, we're gathering the metrics about the specific container. Like Lee was mentioning earlier, you may expect different behaviors from containers because you're hoping that your containers are using your resources. So unlike traditional monitoring, you may expect that your CPU and memory is actually maxed out as much as possible within this specific container because you want it using up and providing valuable service to your application.
Do you find, this is a tricky question, and I don't want this to sound blamey, but the first steps for a lot of users to go to containers is they almost think of them as virtual machines, right? And so you'd say, I'm going to take this thing like SQL Server or whatever else, like SQL Server for Linux, right? I'm going to take that and I'm going to stick it inside of a container. And then you end up with long running containers that use a lot of memory. Like in this case, this thing's been running for 17 days and it's nearly 300 meg. That to me feels like it's a pretty fat container. Do you find that there's a mix, that some organizations maybe are lots and lots of shortly initialized containers that sort of come and go, or are some of them around for a long time? Like I guess Redis would be something that you would expect to be around for a while.
Right, yeah, very much so. And maybe that's one of the things that just sort of early on as containers were being popularized, that there might have been a bit too much bigotry sort of shown toward the appropriate way of running containers, and sort of the microservices way of kind of single process containers that a lot of times people refer to as application containers, and they make this distinguishment between an application container and a system container. And I think sometimes people feel sheepish about running a system container or an infrastructure container. Those that are a bit heavier around the midsection, or those that maybe the image size isn't 293 megs, something pretty small, but maybe it's measured in gigs. Mm-hmm. From my perspective, there's many benefits to running containers, irrespective. How many of those benefits you actually latch onto is up to you.
Yes, I was going to say Redis and SQL Server in terms of memory utilization look a lot, they're pretty similar. So I guess what you're saying is that it really depends on the environment, that some things maybe are perfectly suited to long-running, extremely high-memory services, and then some of them kind of come and go. And you're going to walk us through reporting in a little while and show us that you could actually, for example, run reports that would help you identify those services that tend to run for a long time, or maybe those ones that are a little bit more ephemeral. And because you're still getting all of this historical data for containers that have been running for a month, or maybe just popped in and out of existence for 5 minutes.
Yeah, let me tell you the story that I've been looking at here within my specific container environment. So here I've created a report called Top Container Restarts. So within my specific environment, what I'm looking for is containers that are flapping back and forth, and that the Docker platform or the orchestrator is having to restart because something's wrong with it.
That never happens. Exit code non-zero automatic restart?
Yes.
Oh wait, that's part of the YAML file.
So one of the beautiful things about orchestrators is that they restart your containers when they fail, and they monitor their health and restart them when they need to.
They are tenacious. And
yes. Mm-hmm. We love those orchestrators. So I've created this report that tells me the top 10% of my restarts on my different containers, and luckily for me, my restart count is 0 across the board, so even my top 10% of restarts is 0. So in this case, I'm running fairly well within my environment.
Right, but that's Redis, right? And if that was actually horizontally distributed, and you saw a lot of flapping for your memory store, that would tend to slow down page delivery for your end users.
Exactly. If I were to start to see high numbers in a Redis cache or another type of important service within
Mongo?
Or my Kafka queue that we were showing earlier. If my Kafka queue kept failing, then delivery between my different microservices would be heavily affected, which would show up as latency on my application. So again, we're trying to do that root cause analysis sort of thing of what's causing my application to be slow or what's causing my application to crash. And restart count is one key metric that I'm able to look at. So in addition to having this report that's I'm running every night and letting me know when I have some restarts that get too high, I've also configured an alert. So containers, again, first-class citizens within Orion.
They inherit all the buttery goodness of the platform.
Yes. So I'm able to come into the Orion alerting UI, and once again, I've created an alert that allows me to look at the restart count. So here I'll go to my trigger condition, and as we see, I've started to look at my container, what its restart count, and anything greater than 5. As you saw, my environment was very low with flapping the containers back and forth, so I put it as 5, that if anything does start flapping and it starts to get up pretty high, that's what I want to know about it. So I've created this alert. It's relevant to my environment, and because containers are built fully into Orion, it's easy to do.
But if I wanted to do that based on maybe a dynamic query for the container type or something else, or a time rate, I could add all those elements.
Yeah, or if I wanted to look for somebody who's injecting a bad image that I might not know about, or messing with my environment that in a way that I don't like, I'm able to do that as well.
Maybe they're running SSH in their container.
Don't do that.
And while container orchestrators can help facilitate, these reconciliation loops and make sure that when a container dies unexpectedly to, auto restart, they can really only take you so far. Their level of intelligence is to restart and restart and sort of restart, but then kind of beyond that, you need a tool like this to inform you of it. And, containers end up dying for any number of reasons. I think we were just saying that an image couldn't be pulled. It's a pretty popular issue.
Yep, indeed. All right, so now we're looking at the Orion App Stack page, which you get to by clicking on your environment link from the My Dashboards menu. And here I'm showing off that, yes, indeed, containers are once again within our App Stack, so we're able to look at this in context of the different connections that the containers have to services and whatnot. So here, if I select one of my servers that is running containers, you're able to see which containers it's actually running and which ones are. So
this would be like a Docker Swarm host or a KSpot.
Exactly. So I just clicked on one of my Kubernetes servers that is in my Kubernetes cluster, and here I see specific container instances that are running on that specific server. And I used the power of Orion to indeed build a group that is my Kubernetes cluster, so that I'm able to see now which servers are in my Kubernetes cluster and which ones are participating with those different containers. So this just helps me see all of the different connections that I have within my environment, so I can see internal dependencies between my infrastructure. So if these servers were indeed VMs that were then running on hosts and had some volumes and LUNs and storage behind it, all of that would be visible through that.
Or you have an application that's a mix of microservices, kind of thicker containers, and virtual machines, or other application components, or even APIs.
We just have to stop picking on the thick containers, that's all.
Yeah. And of course, when we're looking at AppStack, we're of course worried about our applications. So I'd like to go quickly into this application that I've created and show exactly what we're doing with this particular environment. So here's an application that I created that is monitoring port 8080 on this specific environment. So I have deployed an app, and part of that app has a service that is listening on port 8080, and I'm really concerned about that service.
And so this is the SAM port template monitor.
Correct. So I've created my own application template with my own component monitor that I've assigned to port 8080, because within this environment, like I said, I need to make sure that that port's up and running. Okay. And so with the flexibility of SAM, I've been able to create this application monitor that is now going to tell me how exactly my application is performing with that specific thing. And I've created it fairly simply, but I hope to show the idea that with the application template monitoring, I'm able to build out my own custom template that allows me to tailor it to my specific application. So now I'm able to treat my application as that first-class citizen, and the different ports that I expose, the HTTP and HTTP services that I have, I'm able to monitor those specifically and then get the full sense of how my application's behaving. And then going back to AppStack, we see that that application is then related to the different pieces within the app stack. So again, I'm treating my application as king and what's actually servicing that application.
And those TCP port monitors can be very helpful to the extent that you're maybe not running an orchestrator. Even if you are, many of the orchestrators will perform an initial health check to make sure that the container spun up, it started correctly, and then doesn't necessarily come back to monitor as deeply as what you were just showing with the TCP monitor.
Exactly, and the flexibility of SAM and some of our other products allow you to dive in deeper, so you could actually jump in and see if that container is a database. You're able to jump in with Database Performance Analyzer. If that container is running some sort of different application, we're able to go in with SAM-specific templates and do HTTPS monitors and different monitors that allow you to actually view inside the application itself.
So you're saying the world isn't just made of containers? Maybe there's other infrastructure to monitor? Is that what's...
Yeah, exactly. And so...
It's evolutionary? IT is evolutionary? Never.
Yeah, so the app stack is really a powerful tool because it's able to show me what my custom application is doing and what containers are servicing that specific application and what servers are running that application. So it's really that one-stop shop again to show me what's running my infrastructure, what's running my application, and how is the overall health of my application.
Okay, so I think most of you out there, and let us know in the chat, if you are using AppStack or you've come to rely on it, because most of you, I think, are. So then the next thing immediately ends up being, we start talking about PerfStack. So how does that work with containers and microservices?
Absolutely. So let's go take a look at some PerfStack or performance analysis from my dashboard. And it just so happens that I built out a interface already for us to look at. So this is something that I think that a lot of you would want to build out.
Oh, yeah.
One, I'm just looking at the average response time to the overall host. So this is my Docker host again that's hosting my application. So just how is it doing with response time? But then I added in my TCP port monitor. So I really wanted to understand what's the latency to that specific port on my application and what's actually going on within my application. So again, the power of PerfStack allows me to add as many metrics as I want to this page and add them all in line so that if I were to see a spike within my application for bad performance, I'd be able to then correlate that to the different containers that we're running. So again, I'm adding the containers and their corresponding CPU load to the PerfStack as well, so that if there was a problem within my environment, I'd be able to zoom in and look at the different issues and the metrics that are associated with the different pieces.
And for those of you who aren't using PerfStack, I mean, we sort of make that boomerang ticket joke, the one that you send off to another team to resolve because the root cause is something that's maybe external to you, and then it comes back because the first thing they reply with is, well, you haven't proved that it's not your systems. This is a great way to do that, especially with containers, where maybe it's something that, I'm not going to say it's scary to another team, but it's just something that maybe they don't understand really well. So that lets you hand them a PerfStack view that lets them see that. One, it proves that it's not your container, for example. Let's say it's something else. But it also lets them kind of learn over time and really become comfortable with the technology and see you as the sort of center of expertise around a new and emerging technology.
And that's a great point. I mean, we've just added more layers as we've added in containers and microservices, and the ability to correlate those metrics across the different layers, super critical. Moreover, if you did get your ticket back, you can imagine that folks may not know just which containers comprise your overall application. And so Carlo, I think you've earned your microservices stripes today with this last diagram, and very clearly there are 4 different containers and X number of those that comprise this microservice, and so this single pane view looks like some of that buttery goodness that you were talking about earlier.
Yeah, I don't want to say this is an Nginx issue, but this sure does look like some sort of a routing issue where I've got 4 different containers that theoretically, if they're all participating in that app and 2 of them are flat, I don't know.
Yeah, well, the beauty of this UI as well is if I had some containers that were short-lived and didn't stay around for too long, in Orion, we're keeping the history of those containers, so I would be able to see and add a container that might only span a short period of time. And if that container, in its short period of history, was spiking up CPU or spiking up memory, I would see that in the overall history of the perf stack. So I'd be able to do some root cause analysis of something happened overnight or something happened a few hours ago and I'm not sure. This sort of time travel ability of perf stack allows me to go back and look. And with the container monitoring addition that we've done, we keep track of all of those containers that were alive over the past week or so, and so you're able to go back and look and see which containers were alive, what were they doing, was something happening, and so this opens up the door to scalability groups and replica groups and different things that you use within the container environments and gives you visibility into how your environment is expanding and contracting with different amounts of traffic and how that is affecting different performance counters within your application.
Yeah, so I think it's not only important that your monitoring tools are able to overcome that ephemerality of containers, and particularly when you've got n number of hosts where containers are distributed across either on-prem things or in public clouds, but you also need this view if you're really going to be able to track the specific signals that matter inside of a multi-service environment. Latency being probably one of those key metrics. So this has been great, particularly in terms of understanding dependencies in and amongst all the rest of your infrastructure. Containers don't run by themselves. Moreover, containers that comprise a microservices application, it's generally not just one container. And so understanding which of those comprise your application, you really need other visibility tooling, other things like distributed tracing.
Yeah. So luckily in SAM 6.7, we have done a really good job of integrating our AppOptics product into SAM so that they're more tightly interwoven. So what we've done is added the ability for you to deploy AppOptics agents to your SAM servers that the SAM is monitoring, and this allows us to then go through and add that distributed tracing power into your SAM environment so that you're able to get that additional layer of visibility. So the power of application performance monitoring with the power of SAM infrastructure monitoring together. So here you're able to see then that we have the metrics that we're gathering from the tracing side by side with the infrastructure monitoring. And that gives you the full picture of how's my infrastructure doing, how's the CPU, how's the memory, how does it look from the outside, right side by side with how does it look from the inside, how are the individual pieces tracking through my application, what are the different pieces of code that are being hit and what's going to the database, etc.
And for those of you who aren't familiar with it, anytime we say the word agent, everybody's ears perk up, well, okay, fine, I'm going to install this thing, what does it do? But in this case, we're talking about actually injecting trackable tokens into those transactions, right? And it sort of depends on the type of application, but it's aware of things like what is Docker, what is certain container types, and then applications and languages, or you can go full custom and actually embed tracing in application code itself at the dev time, so that you don't even have to worry about whether it's going to work with mapping or not later on. You're not applying that after, that thing where they always let's not use the word they when talking about dev. The dev team hands us an application and monitoring is not a part of it, and so often we end up wrapping that later. Well, that agent is a great way because it'll actually apply a lot of that for you and then pop out that relationship and performance data based on those IDs.
AppOptics stands pretty tall here with its distributed tracing. The amount of insight that you can gather in that offering is pretty impressive. Actually, I've heard people take it so far as to say they no longer need logs. They're getting all of the insight that, the deep insight that they need across these containers in this case through tracing. And whether that's true or not, at least here at SolarWinds, we provide really the triumvirate of monitoring between kind of metrics, logs, and tracing. At least in this ecosystem. Certainly we were talking about the longer tail of IT with respect to physical infrastructure and what's provided there.
Yeah, well, you know what we ought to do? Rather than, we could probably do, no, not probably, we have done at least a couple of hours between live episodes and a couple of other how-to videos on how to configure that for AppOptics. So what we got to do, let's throw that into the more information link in the bottom of the session, and so that'll give you a chance. You just click on those and check those out.
Yeah.
Carlo, go back a second. When you were talking about AppStack before PerfStack, one of the things that you mentioned was other dependent services, right? So not just what's running inside of our container infrastructure. Show us what that looks like.
Sure. So let's look at the different available layers within AppStack. And here we have the database instances. So if one of my containers was running a database and I was monitoring it with Database Performance Analyzer, I'd be able to get a deeper insight. Or if I was using SAM to look inside of a SQL Server, I'd be able to get a deeper understanding into what is overall within my application, not only just the containers, but I start to get a fuller picture of if I have a database store behind it. If I'm running a website from my containers, I look to Web Performance Monitor, and I might want to have a transaction that's going through and monitoring my website or my API that is actually fully exercising that part of my application, and that might be fronted by a container.
Are you going to say API economy here? Because well, but really that is the hook. When you start talking about WPM, we're talking about digital experience monitoring, right?
Exactly.
And you might be using Pingdom for that, and Pingdom has some really powerful abilities there. But that idea of what is the experience at the API level, where they're dependent on each other, and so troubleshooting and monitoring is really, really important on each one of those services.
Yeah, one of the beautiful things about containers is that I could be hosting this outside in a public URL, and so Pingdom might be a realistic solution for me, where I have my solution that has accessibility to the public internet. It might be my corporate web page or my corporate API, and I want to see how it's behaving from the world perspective. So Pingdom is an excellent thing for us to integrate in and use to monitor. But within Orion, you have all of that stuff backing up your system. So if you have these containers running on virtual machines or on physical hosts, or you have data behind it, then you've got Virtualization Manager and Storage and Resource Monitor, and all of our different products that we offer from SolarWinds really plug into the greater picture of containers are running on something. They're providing a valuable service. They've got microservices that are providing specific value to you, but overall they're part of a larger picture that is the application that you're running that's on top of some physical hardware that's using a network. So you might be using Network Performance Monitor or NTA in order to analyze your flow. So you're really getting part of a huge picture within this entire infrastructure of how are my applications performing and what is the full picture behind it.
Yeah, you can't contain all of that inside of Docker. You've got network and database and a long, really just like a long tail of other IT concerns that have probably been running your businesses for a very long time. So this is just really one slice of your concerns. And that's what it looks like here.
Exactly.
Well, thanks again for walking us through this. It's so interesting. We started talking about microservices. We ended up talking about containers. And at the end of this session, we got down to Database Performance Analyzer, Storage Resource Monitor. We get down to the standard sort of infrastructure-based monitoring and the dashboards that we're used to. And in the end, microservices just integrate like pretty much anything else.
And to me, there are two key takeaways. Number one, distributed architectures offer real benefits, like scalability. Improved resource utilization, modularity, significant flexibility and speed, and two, At first, containers may seem wildly different than what we're accustomed to, with their use of prominent, Linux and some of its virtualization, really their ephemerality and their sheer numbers. But in the end, they're not all that different.
Right, they use compute, storage, memory, just slices of somebody else's platform. And they also have the same challenges as any service: noisy neighbors, dependency tracking, and configuration, but with a requirement to add new metrics like error rate and accept some realities that are counterintuitive if you're accustomed to IT by trouble ticket.
That is so true. And again, it's just so great to see the adoption of microservices really as an indication that IT is taking on distributed and service-based applications just like any other new thing. It's just really not that big a deal. There's learning and lots of questions to be sure, but it's entirely doable.
That's true. And that's a surprise and also not a surprise. Well, I wish we had more time for this topic, and we'd love to know if we're at least in the ballpark for how microservices affect your operations and where your challenges are. So let us know in the chat if you'd like to see more. Is that it?
Yeah, I think that's great.
I think so.
All right. Well, cool. This has been fun. I'm Lee Calcote.
I'm Carlo Zatilny.
And I'm Patrick Hubbard, and thanks again for attending this session of THWACKcamp.